Good morning, student. Today we discuss group 16 element. Group 16 element consists of oxygen, sulfur, selenium, tellurium, polonium, and livermorium. Now let us discuss occurrence. Dry air contain approx 20.8% oxygen by volume. Sulfur is found in sulfur bed, while the selenium and tellurium are occur as metal selenide and telluride in sulfide forms. Polonium is a decay product of uranium and thorium. Now let us discuss the general electronic configuration of group 16 element. They have general electronic configuration NS2Np4. The general electronic configuration of group 16 element are NS2Np4. In general, on moving down the group, atomic and ionic radii increases because the size of atom increases. Their electronegativity decreases because metallic character increases. Here, now let us discuss the physical properties. Oxygen and sulfur are non-metal. Selenium and tellurium are metalloids, while the polonium is a typical metal. Here one thing must be noted: oxygen is a gas while the sulfur is a solid. It is explained on the basis of their atomicity. Since oxygen is diatomic, its atomicity is 2, therefore exists in gaseous state. But sulfur is octaatomic, since it has 8 atoms in their one molecule, therefore it exists in solid state. Now let us discuss the chemical properties of group 16 element. Number first is the oxidation state. Student, group 16 element generally exhibit -2, +2, +4 and +6 oxidation state. It should be noted the stability of -2 oxidation state decreases down the group since metallic character increases. Similarly, the stability of +6 oxidation state decreases down the group due to inert pair effect. Now let us discuss with the reaction with hydrogen. Group 16 element react with hydrogen to form hydride of type H2E. Here E is the group 16 element. I repeat again, group 16 element react with hydrogen to form hydride of type H2E. Here E is the group 16 element. It should be noted the acidic character of the hydride increases on moving down the group because the bond dissociation enthalpy decreases. That is why we can say that H2S is less acidic than H2TE. Since on moving down the group, bond dissociation enthalpy decreases, therefore acidic character increases. Now let us discuss with reaction with oxygen. Now group 16 element react with oxygen to form oxide of type EO2 and EO3. I repeat it again. Group 16 element react with oxygen to form oxide of type EO2 and EO3. Both type of oxides are acidic in nature. Now let us discuss with the reaction with halogen. Group 16 element react with halogens to form halide of type EX2, EX4 and EX6. Here E is the group 16 element and X is the halogen. It may be fluorine, chlorine, bromine or maybe iodine. It should be noted the stability of halides decreases in order. The stability of halide decreases in order: fluoride, chloride, bromide and then iodide. The stability of halide decreases in order: fluoride, chloride, bromide and then iodide. Now let us discuss a question. Question is given in NCERT. Why H2S is less acidic than H2TE? Since on moving down the group, bond dissociation enthalpy decreases, therefore H2S is less acidic than H2TE. One more question may be arise on this from this topic. Why H2O is liquid but H2S is gas? Since in water molecule hydrogen bonding is there, therefore it exists in liquid state, but in H2S there is no hydrogen bonding, therefore exists in gaseous state. Now let us discuss the manufacturing of oxygen, or you can write it dioxygen, O2. In laboratory, oxygen is prepared by heating potassium chlorate. Potassium chlorate on thermal decomposition gives potassium chloride along with oxygen gas. But on the large scale, oxygen is prepared by electrolysis of acidulated water. Water on electrolysis gives hydrogen and oxygen on the large scale. Here few drops of acid or alkali are added before electrolysis, which make water to a good conductor of electricity. It should be noted, oxygen is colorless, odorless, tasteless gas, is soluble in water, therefore responsible for the survival of aquatic animals. Now let us discuss oxides. Oxides are the binary compounds of oxygen with other element. It should be noted, metal oxides are generally basic in nature, but some metals are there which form amphoteric oxide. These are zinc oxide and aluminium oxide. In general, non-metal oxides are acidic in nature, but there are some non-metal which also form neutral oxide. These are NO and CO. Now let us discuss ozone. Ozone is prepared by passing oxygen through silent electric discharge. If we pass oxygen through silent electrical discharge, we will obtain ozone. Ozone is an allotrope of oxygen. When we pass oxygen through silent electric discharge, we will obtain ozone. Ozone has characteristic smell. It has a germicidal and disinfectant property. Ozone is a powerful oxidizing agent because ozone on decomposition gives oxygen and O, that is called the nascent oxygen, which is responsible for its oxidizing action. It is used for bleaching, wood pulp, etc. It convert colored substance. It convert colored substance to colorless. And the bleaching action can be explained on the basis of their oxidation property of ozone on the thermal decomposition give O2 and O, that is called nascent oxygen, which is responsible for its bleaching action. Ozone is widely used as germicide, disinfectant and for sterilizing water. Now the question arises, how is ozone estimated quantitatively? Student, ozone is estimated quantitatively by reacting when ozone is reacted with excess of Ki solution buffered with borate buffer. I repeat, when ozone is reacted with excess of Ki solution buffered with borate buffer pH 9.2, iodine is liberated, which can be titrated against standard solution of sodium thiosulfate. By this way we can estimate ozone quantitatively. Now let us discuss allotropes of sulfur. As we know that there are two allotropes of sulfur. The first one is the rhombic sulfur. Rhombic sulfur, or we can say it to be the alpha sulfur. Rhombic sulfur or alpha sulfur is yellow in color. Its melting point is 385.8 Kelvin. It is insoluble in water but soluble in carbon disulfide, and it is stable below 369 Kelvin. The second type of sulfur is monoclinic sulfur, or we can say it to be beta sulfur. It is stable above 369 Kelvin. Also, it is colorless needle shaped crystal. Alpha sulfur and beta sulfur both are interconvertible above and below 369 Kelvin. That is 369 Kelvin temperature is called transition temperature, at which both the alpha and beta form coexist. Now let us discuss the structure of sulfur molecule. As we know that sulfur molecule has crown structure which is octatomic. The structure of sulfur molecule is represented like this manner. It is a crown shape in acid form, but in S6 form it is board shape, or you can say chair shape. It is acid. It should be noted, sulfur in vapor phase is paramagnetic. Sulfur in vapor phase is paramagnetic due to presence of unpaired electron. I repeat it again, sulfur in vapor phase is paramagnetic due to the presence of unpaired electron. Sulfur dioxide gas has a pungent smell and is highly soluble in water. Therefore, sulfur dioxide is used in refining of petroleum and sugar. Sulfur dioxide act as a reducing agent. Sulfur dioxide act as a reducing agent. It reduces Fe3 positive ions to Fe2 positive ions. Now, question: how is the presence of sulfur dioxide detected? Students, sulfur dioxide decolorize acidified potassium permanganate solution from purple to colorless. This is the characteristic test for testing sulfur dioxide gas. Now let us discuss the oxoacids of sulfur. In oxoacids of sulfur, the first oxoacid of sulfur is sulfurous acid. Sulfurous acid having formula H2SO3, and the structure of sulfurous acid is H2SO3 is here. The second one is sulfuric acid having formula H2SO4, and the structure is represented like this manner. The third oxoacid of sulfur is pyrosulfuric acid. Pyrosulfuric acid, it is said to be oleum also. Oleum. And the structure of pyrosulfuric acid is here H2S2O7, and the fourth one is the peroxodisulfuric acid. Peroxodisulfuric acid having formula H2S2O8, and the correct structure of peroxodisulfuric acid is drawn on whiteboard like this manner. So these are the some oxoacids of sulfur. The first one is a sulfurous acid, formula H2SO3. Second one is sulfuric acid, H2SO4. Third one is pyrosulfuric acid, H2S2O7. And the fourth one is peroxodisulfuric acid.